Alright, this information begins Chapter 5, and Chapter 5 is one of the most critical chapters of this whole course. So it's important that you're in class if you can be, even if you're not. In the case of this situation with a storm coming in, these will be videos that, that I've listed right here. These are online videos. This is not my video. These are online, and the people that present these is called Fort Bend Tutoring, and it's a good website to get all kinds of math help. They're divided into categories. The introduction on it kind of is the same intro for every one of them, and you can fast forward through the intro until you get to the man that does the instructing on it. Here I've only said you only listen about the first 6 minutes. You can understand what he's trying to tell you here, and it's important that you'll be able to do this information as well. So these two are paired together in two separate things. If you just copy and paste this into your link, you can get it, but my links are all available on Greenwood Math Videos. So this video will be on Greenwood Math Videos on YouTube. Okay, it's on YouTube. You should be able to find it. And I will send the link to that on your homework. So this will be for this week's information, since we are delayed by a storm today. Alright, from 5.1, we already covered some things on the very first day of class that involved polynomials, variables, exponents, terms, coefficients, all of these terms and this knowledge that you should be familiar with. We've already done this. So these things should be familiar to you. Some of this is repetitive. It's just taught in a little bit different way. So in these two examples here, both of these are examples of polynomials. Notice the exponents on the terms. They start with the highest exponent and they go down. Now from exercises on 1.4, we could count this would be x to the first. So if the variables are going down, that this is x to the third, x to the second, x to the first, it would make sense that this would have an x to the 0 on it, because what we learned in that last lesson on 1.4 was that any number to the 0 power would equal to the number 1. And so if I had 1 times negative 9, I'd still get negative 9. So even though this is what we call a constant term, it technically could have a variable behind it, but we would just not see it because it actually simplifies out to be a 1. So that would be the case in both of these problems. This would be x to the first, then we could consider this be x to the 0. So we would see that those variables would appear all the way across. Now notice something is that the powers are getting smaller. So what we call that is decreasing order. So when we write polynomials, we try to make the variables be in, if there's only one variable, we try to make those variables be descending order. Sometimes you see them the other way around, but this is the preferred form. The first term in the polynomial, when it's set in decreasing order, is also the term with the biggest exponent. So we call that the leading term. Okay, it's the first one there. It's got the highest exponent. If a term doesn't have a variable on it, like this 9 didn't, the negative 9 didn't, or the negative 1/2 doesn't, we call that a constant term. Because even though we could put an x to the 0 behind here, the value for x to the 0 would always be 1, so it would never affect the number that's there. So this number is never going to change because it doesn't have a variable that would even ever change it. So leading term would be right here in the front of this one. Leading term here would be the 2/3 x cubed. The constant in the first example would be a negative 9. The constant here would be a negative 1/2. So these are two other terms that we need to be familiar with. Now, a couple of other things. Here we would have coefficients. So if this is our front coefficient and it's on the leading term, we call it the leading coefficient. The 3 is also a coefficient because it has a variable next to it. The -7 is not a coefficient because it doesn't have a variable expression with it, so we call it a constant. So these are the identifying different parts of a polynomial. So in this example, the coefficient of the leading term is 4. The coefficient of that middle term is a 3. And the constant term is -7. So you have to be able to identify the parts of what we're working with. Now, there are different types of polynomials. Poly in general means many. So when we call it a polynomial, that's just a general term. It means it has many sides. So when we talk about many sides, we could have 5 sides or 20 sides or 50 sides, however we wanted to draw that figure. But there are some terms for polynomials that apply to certain situations. For example, if we just have a single term like 2x or a single term like 4x squared, this might be called a monomial. Okay? Mono. If you do a monologue, that's one person speaking. So the term mono means one. In a 2-term polynomial where we have 2x plus y, so we have 2 terms in it, or we have x squared minus 4, this would be called a binomial because it has 2 terms. Bi means 2. A bicycle has 2 wheels. Okay, the third named polynomial would be a trinomial where we have 3 separate terms in the problem. So 2x is a term, y is a term, z is a term. Here x fourth is a term, 4x squared is a term, -4 is a term. So when we do this, we call it a trinomial. So some of your homework problems are going to ask you, what kind of polynomial is this? So you would have to decide. If it only has one term by itself, nothing else, it's a monomial. If there are 2 things together separated by a plus or a minus sign, it's a binomial. And if there are 3 terms separated by positive and negative signs, it's called a trinomial. Anything other than that, we just call it a general polynomial. Now, there's another term that is degree of a polynomial that we have to figure out. The exponent on that term will tell you the degree of the term. When you write the polynomial in decreasing order, which that means you put the highest power in the front, the degree on that leading term will tell you what the degree of the whole polynomial is. So you really, it helps to start with the highest power because that gives us, not only does it put us in the front, it also tells us what the degree is. So for this problem, the degree on my polynomial is a 5. So this 5 tells me that this is a 5th degree polynomial. So the degree comes from the exponent. Okay? The highest exponent. So that would have to be, if we put them in front like we asked for them to be, it's going to be the one right here in the front. A leading term would have the highest power on it, then that power would be your degree. So if I'm supposed to give the degree of this polynomial, I have 7x to the 4th, 6x squared, x to the 1st, and I've put it in decreasing order or descending order. So this is my leading term, and it also has my highest power. So this would be called a 4th degree polynomial. And since it has 3 terms, we're going to call it a trinomial. So if they ask you what kind of polynomial is this, you would call it a trinomial. If they ask what degree does it have, you would say it has a 4th degree. So you just count the exponent, take the highest exponent, that's going to be your degree. Now, that's the only new stuff that we really kind of have to talk about. The rest of this is just combining like terms like we've already done. So this first one, combining like terms, is the process of just adding and subtracting whatever terms you can. Terms can only be combined if they have exactly the same variable part. The variable expression has to be the same. Now, when you're adding or subtracting like terms, you never change the exponent. Okay, when what? Adding or subtracting. Never change the exponent. Only combine the coefficients. And those are the numbers that are out in front. So, examples. Here I have a 6x plus I have a negative 15x. Now, if there is an addition between two expressions that are in parentheses, you can just drop off the parentheses and just forget that they're there and then just add the like terms. So I'm going to ignore the parentheses and just have 6x minus 15x, which would be negative 9x, and a negative 9 plus 4, which would be negative 5. And then this would be simplified. That's all I can do. That's combined like terms. Alright, number 2, I've got my highest term. So when you're looking to put your answer in descending order and you want the highest term, we'll pick out all the numbers that have the highest terms. So I'm going to start with my 9a squared. Over here, it's a plus. So all I'm going to do is forget that there's parentheses and just combine the numbers together. So 9a squared minus 5a squared would be 4a squared. Then I have a negative 5a, and over here a negative 6a, so that would be negative 11a. And then negative 6 and a positive 9 would give me positive 3. So there's my leading term, there's my middle term, and there's my constant. Right? Now on the bottom, here you have to be careful because you've got to make sure that they are the exact same expressions. So I'm still adding terms together. I'm adding polynomials together. So I've got a 4, but the term is an x squared y. So over here, I'm looking for x squared y. Okay, so these two have exactly the same expressions. So then I'm going to have 4 minus 9 would be negative 5 x squared y. The type of thing does not change. It's the amount of the things that change. Now my next term has an x and a y squared. So this one's a different kind. X, y squared. There's some more x, y squares. So now I have negative 5 and a positive 10 would be positive 5 x, y squares. They don't change into something different. And then the last terms I have constants. So I have a positive 5 and a negative 6, which would be negative 1. Okay, so this note right here is important. When you're adding or subtracting like terms, never change the exponents. You're only combining the coefficients on the front. Okay, when you rewrite the terms or you move them around, remember that the sign that's in front of that term belongs to it. So don't drop it off. It has to stay with it. This is still going to be a negative 5 if I switch places around. Alright, so now adding, and that's adding. Now when we subtract and they're written in polynomial form, it's like what we did when we're distributing a negative 1. Okay, so that negative sign that's right there in front of the parentheses just means that there's really a negative 1 in front of the parentheses. So basically you're going to distribute that negative 1, and after you distribute it, then you're going to just drop off those parentheses, because then it would just look like 4x minus 19. Distribute the negative 1, so it's just going to change your signs, minus 4. So now I drop off all the parentheses. I have distributed the negative to every term in the parentheses, and now I just come back and combine my terms like I did a while ago. So I have a positive 4x and a positive 2x, so that would be 6x. Negative 19 and negative 4 would be negative 23. That would be your final answer. Over here in the middle, I can see I've got a negative sign. I can't just drop off the parentheses because I need to distribute that negative 1 that's there first. So I'm going to multiply everything by a negative 1 that's in this back. So that's just going to change all these numbers, and it's going to change their signs. So this becomes negative 7x cubed minus 2x squared plus 3x, and minus 9. On the front, I'm just going to bring it down and take it out of the parentheses. So the front one doesn't change, only the one that is behind that negative sign in front of the parentheses. Now go back and combine like terms. So I've got my highest power is an x to the third, so I'm going to look for all the x to the thirds. Well, there's 5 here and negative 7 there, so my x to the third would be negative 2x to the third. Then I'm going to do my x squares. Okay, so I've already got that one done and that one done. Negative 3x squared and a negative 2x squared. I still have x squares, but now putting them together I have negative 5x squared. Okay, so I got the x squares done. I've got negative 4x and positive 3x. So there's more negatives, so that will be negative x. Got those done. And then look at the constants. I have negative 7 and negative 9, which would be negative 16. So here would be our final answer. We can't do anything else to it. Same thing goes for this one. Alright, now number 3 has an addition between the first two and a subtraction at the back. So I'm going to put that as a negative 1. The first thing I'm going to do is distribute that negative. Where there's a plus, I don't have to worry about it. So I'm just going to take them all out of the parentheses now. Minus 2x squared. I'm just going to string them along and have one giant expression. So this then becomes negative x squared, negative x, and negative times negative would make positive 1 at the back. Now go collect everything. So I'm going to start with the highest power, so I put them in descending order. So the only x cubes are right here in front, so that'll be my first one, 5x cubed. Okay, got him done. Here's a negative 2x squared and a negative 1x squared, so I get negative 3x squares. Got the squares done. X's, negative 3 and a positive 7. That would be 4. And then over here's one more, minus 1. So 4 minus 1 would be plus 3 x's. And I've got all the x's done. So now I look at my constants. 10 plus 4 would be 14, plus 1 would be plus 15. And this would be your final answer. You just have to remember, if there's a minus in front of the parentheses, you have to distribute it to all of the numbers in the parentheses, and then you can combine like terms. Now, the multiplication of polynomials is a little bit different, because when we multiply, we are going to change the powers, because it's changing the number of items that are being used as a factor. Well, the first case is just very simple. That's just what we got through doing in exponents. So if I have coefficients, I'm going to multiply 24 times negative 3. This is not a negative exponent, it's just a negative 3. So 24 times negative 3 would be negative 72. And then I'm going to say, okay, this is 3 x's strung together, and now they're telling me to put 4 more along with it. That would mean I have x to the 7th power. Here I have y to the 4th. And then I've got 4 y's that are being multiplied, and over here I would put 3 more in the bucket. So now I have y to the 7th. So if I did not have that problem in exponent form, I would have to write 7 x's down, and I would have to write 7 y's down. This just makes it shortcut. That's why we use exponents. Alright, the next one is just distributing. We did this already. So I'm going to multiply the number in the front times each thing in the parentheses, and I use my power rules. So 7 times 3 would be 21. I have x to the 3rd, so that's 3 x's, and I'm going to multiply 1 more in there, so that would be x to the 4th. Then I have 3x cubed times just a negative 4, so 3 times negative 4 would just be negative 12x cubed. So these should not be anything unfamiliar to you. Just multiply. Every time you multiply, there's powers that are going to change if there's other x's there. So I have a negative 4 times 3 would be negative 12. And then I have 2 factors of x, so it would be x squared. Multiply the next one will be negative 48. I have 1 factor of x and 2 more, so that would be x to the third. At the back, I have negative 4 times negative 5 would be positive 20. And then 1x and 3 more would be x to the fourth. That's your answer. That's as simplified as you can get, because that's a squared, that's a cube, and that's a fourth. We can't combine things together that have different exponent values. Alright, number 3, x cubed y, and I have a negative sign. So because there's a negative there, everything inside has a sign change on it. And then we've got to fix our variables. So I have negative 3. I have 3 x's, and I'm going to add 3 more to it. That'll be x to the 6th with a y value. Then negative times negative would make positive 4. I have 3 x's plus 2 more would be x to the 5th and a y. And then negative times positive, so that would be negative 7. That 3 plus 1 more would be x to the 4th, and there's a y that goes along with it. So this would be your final answer. Be careful on this, and typing these problems in on your homework is not fun because you're having to type exponents. So be careful as you type those answers in. Right, so these 3 are answers. Now, the third way to multiply is when we have 2 binomials that we're going to multiply together. It's the very simplest of multi-terms with polynomials. So 2 by 2 would be the very simplest. You could have a 2 times a 3. Or you could have one that looks like this times one that looks like this. Okay, those would be long terms drawn out. That would be a big problem. Now, when we multiply 2 binomials together, we use a process that the reason that we use it is because the letters of the word help tell us the order to work in. So the method that we're going to use is called FOIL, and most of you will remember that from high school. The letters come from words, okay? So the first letter comes from the word first, F-I-R-S-T, so that's where the F comes from. Then the next one comes from the word outer. There's an O, so F-O. The next one would be inner. So there's the I in the FOIL. And then the next one would be last, and that would be the L. So that first, outer, inner, last tells you how to multiply the numbers together. So first says take the front of each parentheses. So I'm going to multiply the A times the C. There's my answer, AC. Then O stands for outer. So I'm going to take the 2 that are farthest apart from each other. These 2 right here. A times D. So that would give me AD. Then inner are the 2 that are closest to each other. They sit back to back. So B times C. There's BC. And then the last would be the ones that are at the back of each set of parentheses. So B times D would give us BD. Now, we're going to be working with numbers on these, and you're going to see that they'll combine together and they do some other things. Now, FOIL tells you an order to multiply the terms in the parentheses. Multiply the front terms of each parentheses, then multiply the 2 on the outside, the ones that are farthest, the 2 that are farthest away from each other, then multiply the 2 that are closest to each other, and then you multiply the last in each set of parentheses. So first, outside, inside, last, or first, outer, inner, last. That's all it does. It's just telling you the order to do it, and that way you know that you've done all the multiplying that you need to do. So it's just a process, and you'll learn it, and as the more you do it, you'll get really good at it. So here's an example. x plus 3, so I have two terms in a parentheses. That's a binomial. Here I have two terms. That's another binomial. And I want to multiply those two together. So I'm going to multiply the first. So the first term in each one is x times x. That's going to give me x squared. Then I'm going to do the outer, the two farthest away from each other. So this would be my first. This would be my outer. So 2 times x, or x times 2, would just be 2x. Okay, then I'm going to do these two. These would be my inner, because they're the closest together. So 3 times x would be 3x. And then the last would be the 3 times the 2. And 3 times 2 would be 6. Now, I'd have x squared plus 2x plus 3x plus 6. But if you notice, this inner term and the outer term, they are like terms because they both have x to the first power. So I'm going to combine those together into one term, and I'll be finished by having x squared plus 5x plus 6. And this would be my final answer. So most of the time when you multiply two binomials, you'll have something that combines together in the middle. Doesn't always have to happen, but most of the time it will. So now, let's go to multiply using the FOIL method. So my first two would be 5x times 2x. That's f. So 5x times 2x would be 10x squared, because that's going to give me two terms of it, two copies of x if I wrote it down. Okay, my outer would be 5x times 3, so that's plus 15x. The inner would be 4 times 2, which would be 8x. And the last would be plus 12. So now, go back and look. Are these like terms in the middle? Yes, they are. So I have 10x squared plus 23x plus 12. And this would be my final answer. So if I start out with two binomials and we have something that combines together in the middle, then I end up with a trinomial answer. Okay, let's try the next one. First would be 3x times x, so that would be 3x squared. My outer would be 3x times 5y, so that would be 15xy. The inner would be 7y times x. Now, it doesn't matter the order that you put them in, but basically you put them in alphabetical order. So that one's be negative 7xy. And then the last would be negative times positive, so it would be negative 35y squared. Now the two middle terms are both xy terms, so they're like terms. So I have 3x squared. 15 minus 7 would be negative 8xy, and minus 35y squared. So this would be the final answer for multiplying these two polynomials together. Okay, now this one is kind of a special one. Watch what happens on this one. Notice here I have 5x and a positive 7y, and here I have a 5x and a negative 7y. Now notice what happens. When I multiply 5 times 5, I'm going to get 25. X times x would be x squared. Okay, my outer terms would be 5 times negative 7, so negative 35xy. The inner would also be 35, but this time it's positive 35xy. And the last would be 7 times negative 7, which is negative 49, and y times y would be y squared. Now in the middle, notice what happens this time. I have a positive and a negative 35. So those are going to cancel each other out, so those subtract off, and I'm just left with 25x squared minus 49y squared. So the middles, by the fact that the numbers were exactly the same and one was a plus and one was a minus, they basically allow the middle terms to cancel each other out, and you're only left with the front and the back. Okay, now, here's a warning sign. It doesn't matter how many times you think that your idea might work, this kind of thing will not work. Okay, exponents, unlike multiplication, do not distribute over addition, okay? So that means this 2 doesn't just go to the 5x squared, and it doesn't just go to the 6. It cannot be distributed. That's what it's saying, okay? Here's an example. If I have 3 plus 4, and on the outside it says squared, do not give in, that's what succumb means, to the temptation to make it be 3 squared plus 4 squared. Okay? Because if you look at the problem, 3 squared plus 4 squared is going to be 3 times 3 would be 9, 4 times 4 would be 16, and 9 plus 16 would be 25. Okay? But that's wrong, because if you have 3 plus 4, you can add 3 plus 4 together, and in PEMDAS it would say you have to add 3 plus 4 together. 3 plus 4 would make 7, and then when we square 7, we get the answer of 49, not 25. Okay? Now, here's the thing you have to recognize. When this says 5x minus 6 is to be squared, the exponent tells us how many times we need to write this expression. So this problem means 5x minus 6, parentheses 5x minus 6. So that too means you have to write it twice. Okay, then you're just going to FOIL it. Same thing here. 6a plus 9b, and I want to square the whole thing. That means everything in here has to be written 2 times. So this problem becomes 6a plus 9b times 6a minus 9b. Now when you FOIL it, 5 times 5 will give you 25x squared. 5 times negative 6, your outer will be negative 30x. The inner, 5 times negative 6, will also be negative 30x. But those are not opposites now. They're not going to cancel each other out. See, that only happens if one is plus and one is minus. See the difference? Plus and minus makes the middles fall off. Plus and plus, or minus and minus, they're not going to fall off. Then go to the last, would be negative 6 times negative 6 is positive 36. Now you can combine those two, and you get 25x squared minus 60x plus 36. And this would be your final answer. So on number 7, this says it has to be squared. Actually, this is number 4, and this is number 5. This says it has to be squared, so I write it down 2 times. That's what the exponent means. Now you're just going to FOIL it out. So 6 times 6 would be 36a squared. The outer, 6a times negative 9 would be negative 54a. The inner, 2 closest together, would be plus 50. Whoops, this is supposed to be a plus. I'm sorry. Plus 54a and plus 54a. Outside would be plus, inside would be plus, because they're both plus. And then the last would be positive 9 times 9, 81b squared. So now these are both positive in the middle. I'm going to add them together, and I get 36a squared plus 108a plus 81b squared. And there's my final answer. So here's the thing. If the numbers are exactly the same and the signs are different, the middle term is going to subtract off. But when you write this twice by the fact that it's being squared, now the signs in both are exactly the same. So you are going to get a middle term here. Here's the same way. They're exactly the same term twice. So you're going to FOIL it out, and you're going to have a middle term in your answer, 336a squared plus 108a plus 81. Okay, the only way you're going to get good at using FOIL is to practice and practice. You cannot wait until the end and do this work. You have to do it because we're going to be using it all along in Chapter 5. The only way you get good is practice. Multiplying binomials will have some patterns in it, and it's going to allow us to take some shortcuts in certain situations, so you can be prepared to do that. So the next lesson will be on dividing polynomials. We're not going to do dividing in this section with 5.1. We're going to do it in a different section.